Our Sun, the life-giving star at the center of our solar system, has fascinated humanity since the dawn of consciousness. The concept of the age of the Sun encompasses both the scientific understanding of our star's lifespan and the poetic inspiration it has provided throughout human history. The Sun formed approximately 4.6 billion years ago from the gravitational collapse of matter within a region of a large molecular cloud, and is currently about halfway through its main sequence life phase. This cosmic timekeeper not only illuminates our physical world, but also our artistic expressions, as evidenced by works like Ehigiator's Anthology, Age of the Sun, an anthology of poems on nature, which celebrates the Sun's enduring presence and symbolism in our lives. In this exploration, we will delve into both the scientific understanding of our star's age and evolution, as well as its cultural significance as a source of poetic inspiration. The formation of our Sun occurred approximately 4.6 billion years ago, emerging from the collapse of a fragment of a giant molecular cloud composed primarily of hydrogen and helium. This age estimate relies on computer models of stellar evolution and nucleocosmochronology, aligning perfectly with radiometric dating of the oldest solar system material at 4,567 billion years ago. Evidence suggests that one or more nearby supernovae likely triggered the Sun's formation, as ancient meteorites contain traces of stable daughter nuclei from short-lived isotopes that only form in exploding short-lived stars. As the cloud fragment collapsed under its own gravity, it began to rotate due to conservation of angular momentum while simultaneously heating up from increasing pressure. The majority of mass concentrated at the center, with the remainder flattening into a disk that would eventually form the planets and other bodies in our solar system. The intense gravity and pressure within the core generated tremendous heat as more matter accumulated, eventually triggering nuclear fusion and birthing our Sun. Dating our star involves several indirect methods that consistently point to an age of approximately 5 billion years. Scientists like G.J. Wasserberg have obtained meteoritic ages of 4.57 plus 0.01 billion years, with estimates suggesting that hydrogen burning in the Sun's core began about 40 million years after initial formation. Additional evidence comes from Earth itself, where the oldest rocks date back approximately 4.6 billion years, while the oldest fossils discovered in Australia are roughly 3.5 billion years old. The presence of these ancient fossils indicates that Earth was already habitable when they formed, implying that the Sun was already luminous and stable at that time, providing a lower boundary for its functional age. The Sun currently exists in what astronomers call the main sequence phase, the stable middle age of a star's life, when it steadily fuses hydrogen into helium in its core. Our star is approximately halfway through this phase, which will last a total of 10 to 11 billion years before transitioning to the red giant phase. Every second, the Sun's core converts more than 4 billion kilograms of matter into energy through nuclear fusion reactions, producing both neutrinos and the solar radiation that makes life on Earth possible. At this conversion rate, the Sun has transformed approximately 100 times Earth's mass into energy, representing about 0.03% of the Sun's total mass since its formation. During its main sequence lifetime, the Sun is gradually changing, becoming hotter at its core and surface, while expanding in radius and increasing in luminosity. Since the beginning of this phase, our star has expanded by 15% in radius, while its surface temperature has increased from 5,620 K to 5,172 K, resulting in a 48% increase in luminosity, from 0.677 to 1.0 solar luminosities. This occurs because the helium atoms accumulating in the core have a higher molecular weight than the hydrogen atoms that were fused, leading to less thermal pressure and allowing the Sun's outer layers to move closer to the center, releasing gravitational potential energy. Currently, the Sun's brightness increases by approximately 1% every 100 million years, though Earth's liquid water will remain viable for at least another billion years before this increasing luminosity renders our planet uninhabitable for complex life. The Sun's future will involve dramatic changes both internally and externally once hydrogen fusion in its core ceases. As the Sun evolves off the main sequence, it will enter the red giant phase, expanding dramatically to approximately 256 times its current size with a radius of 1.19 astronomical units, large enough to engulf Mercury, Venus, and potentially Earth. During this billion-year red giant branch phase, the Sun will lose roughly 1/3 of its mass. Following this expansion, the Sun faces another critical transition when its core, now filled with degenerate helium, ignites violently in what astronomers call the helium flash. Within mere minutes, approximately 6% of the core, itself comprising 40% of the Sun's mass, will convert to carbon through the triple alpha process. After the helium flash, the Sun will contract to about 10 times its current size, while achieving 50 times its present luminosity, entering what astronomers call the horizontal branch or red clump phase. Unlike some stars that evolve blueward along the horizontal branch, the Sun's particular metallicity will cause it to simply become moderately larger and more luminous over approximately 100 million years as it continues to fuse helium in its core. When this helium supply eventually depletes, the Sun will repeat its expansion pattern, entering the asymptotic giant branch phase, where it alternately fuses hydrogen and helium in shells around its core. During this unstable period, lasting about 20 million years, the Sun will experience rapid mass loss and thermal pulses that dramatically increase its size and luminosity for brief periods every 100,000 years, with later pulses pushing its brightness to as much as 5,000 times its current level. Beyond scientific study, the Sun has inspired countless artistic creations, including Ehigiator's Age of the Sun, an anthology of poems on nature. This collection has been described as a liturgical ode to nature that inspires positivity and progress through its careful use of imagery and symbolism. Readers have praised the anthology for its ability to highlight the beauty of nature and the valuable lessons we can learn from careful observation and appreciation of our natural surroundings. The book's thoughtful design includes a header image of the Sun before each poem, serving as a subtle reminder of the collection's solar theme. The anthology is structured as 3 distinct trips or sections that explore different aspects of our relationship with nature. The first section celebrates nature's beauty, while the second emphasizes tolerance and environmental preservation. The third section draws parallels between natural elements and human challenges, exploring the steadfastness of trees, the bravery of skies, and the relevance of waters, among other natural motifs. Through these comparisons, Ehigiator suggests that we are never alone in our struggles for a better future, as nature provides both companionship and inspiration. The collection includes poetry, addressing discrimination, segregation, and hatred, while also offering inspiration, encouragement, and thought-provoking messages intended to transform readers. The Age of the Sun represents both a scientific timeline of roughly 4.6 billion years of stellar evolution and a poetic metaphor for endurance, constancy, and inspiration. From its birth in the collapse of a molecular cloud to its current middle-age stability and eventual dramatic expansion, our star's life cycle offers perspective on cosmic timeframes far beyond human experience. Meanwhile, literary works like Ehigiator's Anthology remind us of the Sun's enduring symbolic importance in human culture. Whether studied through the lens of astrophysics or celebrated through poetry, the Sun's journey through time continues to illuminate our understanding of both the universe and ourselves. As we contemplate both the scientific and artistic dimensions of the Sun's age, we gain a deeper appreciation for this central force in our existence and the multiple ways humans have sought to understand and express its significance.